Hello friends, in this video we are taking the another example for doing merge sort. In the previous video I told you how to apply merge sort on an array. In this video we will apply the same technique but on different example. The array which is given to us which we need to sort having 10 elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So as we have already discussed what we need to do, first we divide our array into two halves, then two halves will divide it further into two halves and the process will carry on until unless we will get the array of single elements. So let us divide this array into two parts. After dividing the initial array into two halves, now we will divide it the next two array into another two halves. But this time our array is having odd number of elements. So as we have already discussed, if this kind of things happen, so the left array will have higher element as compared to the right array. So it will have 4, 1, 3, 2, 16, 9, 10, 14, 8, 7. Now we are having four arrays and these four arrays will further divided into the 8 arrays. This array is having 4, 1, it is having only single element 3, it is having 2, it is 16, it is having two element 9 and 10, it is having single element 14, it is having 8 and it is having 7. Many of the partitioned array are having single element, but still few of the arrays are having more than one element. So it means we need further partition. So this array will divide it and this array will also divide it. And these arrays will remain undivided because they are having only one element. So 4, 1, 3, 2, 16, 9, 10, 14, 8 and 7. So after dividing, because in the merge sort the conquering is not required, so we directly combine them. And when we combine them, we will follow the approach of the merge sort. In the resultant array, when we are merging two of the element, we will make an order. The order will be depend on the resultant output. If we want to sort our data in an ascending order, so the lower value will come first compared to the higher value. So this part, this combining part or the merging part, we will do into the right hand side of this board. So for this, I need to write it again. 4, 1, 3, 2, 16, 9, 10, 14, 18, 7. Always remember, whenever you are combining, the two arrays will combine in the same order in which they were divided. It means the 4 and 1 will combine first in the output of 1 and 4. 3 will remain unchanged. 2 and 16 will combine. 2 and 16. 9 and 10 will combine. 9 and 10. 4, 14 will remain same and then this array will combine. When these two elements are combining, so remember that we should maintain the order now. Now these two array will combine further to make the resultant array. 1 4 in the first part and the second part having 3 as an element. So what will be the output? 1 3 4. This will remain unchanged because you cannot merge it right now with any other element, and these two array will merge right in this particular output one array. So it will be 9 10 and 14. This array will remain unchanged. We need to be careful about that, in which order we have divided that. In the same way we need to merge them. Now these two array will merge, and these two array will merge into this array. And if we are having more elements, then you can understand better how the two arrays are merging. So let us do directly into this step, but in the next step I will show you the way of merging. So it will be 1 2 3 4 6, it will be 7 9 10 14 and 18. But how it happens, I'm showing it here. I've already told you in the previous video, but don't worry, I will tell you here also. So this is the array. This is the left hand side of array. We are having a pointer which is pointed by L. In this array we are having a pointer R. The L pointer is pointing the first element of left array, and the R pointer is pointing the first element of right array. We will compare the value of the both array which is pointed by respectively L and R. Whichever is the smallest value compared to them, after comparing them, that will store into the resultant array first. So 1 and 7 are compared, pointed by L and R respectively. So 1 will be here and the L will move to the second element. And 2 and 7 will be compared. So 2 will be stored into the resultant array and L pointer will move. Then 3 and 7 are comparing. So 3 is coming here and the L pointer is coming here. Then 4 and 7 are comparing. So 4 is coming here and the L pointer are moving here. Then 6 and 7 are comparing. So 6 is coming here and the L pointer reach to the at the end of the first array, because in the second array R pointer has not moved, but it happens, no, not a big deal here. We never bothered about that. But if the any of the arrays reach to the end of the in any of the array, if the pointer reach to the end of the array, then all the in the other array, in the second array, all the element will stored into the resultant array in the same way in which they are present into the previous array. So it means in this array all these elements will store into the same order, and you can find this is the output and all of the elements are sorted. Thank you.